Hello, everybody. Michael's back again. I am back again, talking in the third person, but we are doing Python Crash Course again. I'm in chapter 10. I actually completed the chapter 9 on classes in the last stream, I believe. And, or not in the last stream, I was streaming the MIT discrete math course. Really hard stuff, I'm not gonna lie. It's not, super challenging, like actually the work, but it's just like the thought process is really hard. But I'm excited to study today and learn. Had a good day at work. So let's go ahead and get into this. So we are learning about file pathing in chapter 10. We learned about importing pathlib and then importing from pathlib, importing path, which is a class that creates objects, right? Which is what classes do, and it creates objects of paths into your file system on your computer, and you can actually read and write files. So I have some familiarity with this already using CSV, but it looks like path would be what you would use to read like .text files, things along those lines. So let's get right. Let's keep moving here. So I believe I was on accessing a file's lines. When you're working with a file, you'll often want to examine each line of a file. You might be looking for certain information in the file, or you might want to modify the text in the file in some way. For example, you might want to read through a file of whether they have the wrong weather here. They have weather like of weather data. No, it's supposed to be of weather data and work data with any line that includes the word sunny in the description of that day's weather. Okay. In a news report, you might look for any line with the tag headline and rewrite that line with a specific kind of formatting. You can use the split lines method to turn a long string into a set of lines, and then use a for loop to examine each line from a file one at a time. So from pathlib, import path, and path equals path object with your file inserted, pydigit.text contents equals path dot reader text read text, lines equals content dot split lines, for line and lines, print line. You can use the split line method to return a long string into a set of lines. Okay. Okay. We start out by reading the entire contents of the file as we did earlier. If you're planning to work with the file and the individual lines in a file, you don't need to strip any white space when reading the file, right? Because the path object returns or the read text method returns a blank line at the end. Thirsty. So we start out by reading the entire contents of the file, as we did earlier. If you're planning to work with the individual lines in a file, you don't need to strip any white space when reading the file. The split lines method returns a list of all lines in the file, and we assign this list to the variable lines. Okay, so lines content dot split lines. Okay. The split lines method returns a list of all the lines in the file, and we assign the list to the variable lines. We then loop over the lines and print each one by one. Since we haven't modified any lines, the output matches the original text file exactly. Working with a file's contents. If you've reached the contents of a file's in memory, after you've read the contents of a file into memory, you can do whatever you want with that data. So let's briefly explore the digits of pi. First, we'll attempt to build a single string containing all the digits in the file with no white space in it. From path lib import path. So lines, content, split lines, pi string equals blank string, for line and lines, pi string plus line. Print pi string, print the length of the pi string. We start by reading the file and storing each line of digits in a list, just as we did in the previous example. We then create a variable pi string to hold the value digits of pi. We write a loop that adds each line of the digits to the pi string. We print this string and we also show how long the string is. The variable pi string contains the white space that was on the left side of each of the digits in the line. We can get rid of this by using the L strip on each line. Pi string plus or minus line dot L strip. Now we have a string containing pi to 30 decimal places. This string is now 32 characters long because it also includes the leading 3 and a decimal point. Yeah. When Python reads from a text file, it interprets all the text in a file as a string. If you read in a number and want to work with that value in a context, you'll have to convert it to an integer using the int function or a float using the float function. Large files, 1 million digits. So far we focused on analyzing a text file that contains only 3 lines, but the code in these examples would work just as well on much larger files. If we start with a text file that contains pi to 1 million decimal places instead of just 30, we can create a single string containing all these digits. We don't need to change our program at all except to pass it a different file. We'll also print just the first 50 decimal places, so we don't have to watch a million digits scroll by in the terminal. So if we start with pi to path pi 1 million digits dot text pi string, a slice of the pi string from 0 to 52 up to 52. Okay, yeah, the 3 dot, so we want another 3 decimal. Okay. The output shows that we do indeed have a string containing a pi to 1 million decimal places. Python has no inherent limit to how much data you can work with. You can work with as much data as your system memory can handle. To run this program and many of the examples that follow, you'll need to download the resources available at HB. Okay, yeah. To run this program, okay. Is your birthday contained in pi? I've always been curious to know if my birthday appeared anywhere in the digits of pi. Let's use the program we just wrote to find out if somewhere in the birthday is some if we just wrote to find out if someone's birthday appears anywhere in the first million digits of pi. We can do this by expressing each birthday as a string of digits and seeing if that string appears anywhere in pi string. Birthday pi, for line and lines, pi string equals line dot strip. Okay. Birthday equals enter your birthday from the form. If birthday in pi string, print birthday appears in the first minute, else your birthday does not appear. We first prompt the user for the user's birthday and then check if that string is in pi string. Let's try it. Enter your birth date in the form of month, day, year. Okay, 12/03/72. Your birthday appears in the first million digits of pi. My birthday does appear in the digits of pi. Once you've read from a file, you can analyze its contents in just about any way you can imagine. Learning Python, okay. Cool, so we are... Where's my terminal at? It's up here. Let's bring it down here so we can see outputs easier on here, and let's go, we want to cd python work right? And we want to make dir chapter 10, cd chapter 10. We want to touch 10-1 learning Python. Okay, so chapter 9 had a lot of problems in it. Let's try chapter 10 here. Chapter 10-1. Okay. Open a blank file in your text editor. Okay, we need to touch. Oh. And write a few lines summarizing what you learned about. Touch text dot txt. So let's open this bad boy. Let's just open a blank line, write a few lines summary when you learned about Python so far. So far in Python, I have learned how to do the following. Number 1, we learned how to use, we learned about variables. Number 2, we learned about functions. 3, we learned about loops. 4, we learned about classes. 5, we learned about file IO. Cool. So there's my 6 lines of code in this txt file. So let's open up this guy here. Open a blank file in your text editor and write a few lines summarizing what you've learned about Python so far. Start each line with the phrase, in Python you can. Okay, well, I didn't do that, so we gotta do that. In Python, use variables to represent data. In Python, you can use functions to repeat repeat tasks. In Python, you can use classes to represent real world data. Okay, here's my 3 lines. Save the file as learning python.txt. Okay, let's go rename. Learning python.txt in the same directory as your exercise from this chapter. Write a program that reads the file and prints what you wrote 2 times. Print the contents once by reading the entire file and once by storing the lines in a list and looping over each line. Okay. That doesn't seem too bad. Let's go ahead and actually, let me open up a Safari. I want to actually start get some music going here. I'll put in my headphones. Getting an ad, hold on. need to have some music, though. Alright, let's just, I'll be right. It's Halloween time. That's in all the way. Okay, this one's not that good. Let's just do this one. Alright, let's turn that down. There. Alright, cool. I think that's probably good, like right there. Alright, let's keep moving here. There you go. Okay, so we have our file here with our text. Write a program that reads the file and everything. Okay, so what we need to do is we need to from path lib import path, right? Gotta import path. And then we need to actually create our file. So we have our file equals path, which is gonna be quote learning python.txt, right? And then we need to read the contents of this file object. So we need to do file dot file lines file content equals I'm gonna do file dot read text, right? Yes. So then this should just have our text in there. So now if we clear and then we do .rstrip, right? Let's remove all the white space on the content, the read text from the bottom. Now if we actually just run this program, we get nothing. We need to actually print the file content right now. There we go. So now we get the file content in the lines, right? So this was okay. This was print file content using read by reading all the text, returning one string, right? And so then here we're going to do it again. We are going to print file content by splitting the lines and looping through each line. Okay, so what we need to do is we have our file path already, so I'll leave that. So I'll take this, I'll move it down one here. So now we will take our file path. We'll take file content. No, we don't want to override. We want to do file lines equals file dot split lines. Yeah, so you have to have the read text. Split lines. So, did I not just, what happens if I just click this? Run this again. So I do get that. Print the content once by reading the entire file and once by storing the lines in a list and looping over each line. Yeah, is equal to file content, right? Dot lines. And then, so this is returns a list. So if I just print the file content or file lines, right? Just like so, and I actually comment out this print so I can just get a better view, and then run, I get a return a list of each line, right? And it actually removes, so what happens if I take out this R strip and I reprint? So yeah, it removes why did he stop using R strip? Working with it applies the R strip method. Read text. I think he's forgetting the R strip. I'm not sure why he removed it from his, because the read text would return, but split lines doesn't take blank line. Doesn't ever return a blank line on read text. But it does for this, right? right? I get a blank line. So we'll keep the R strip, right? We'll keep that there. So instead of printing just the list of lines, we want to go for a line in file lines, right? We want to, he just adds it to the end of the list. He doesn't even append it, he just adds plus equals. We want to return, store the lines in a list. Print the content once by reading the line and once by string. So now, if I clear this, we get that. We get each line. Right, we just print the line. So if I uncopy this or undo this and run it, we should get it twice. I'm gonna leave the R strip off so we get that spacing actually on this circumstance, and that'll work out. Optionally add R strip to remove bottom. New line. Okay. Cool. Learning C. Alright, we want to touch 10-2. Okay. You can use the replace method to replace any word in a string with a different word. Here's a quick example of how to use the replace. Dog with cat in a sentence or message. I really like dogs. Message dot replace dog cat. Okay. I really like cats. Read in each line from the file you just created and replace the word Python with the name of another language such as C. Print each modified line in the screen. Okay, so from path lib import path, right? We want to create a file variable and actually access our file using the path object. We will insert our file name here, learning Python .txt. We will get the file contents by reading the text of the file using the read text method. So now we have the lines in the file, or the text in the file. So now we can just say file content dot replace. We want to replace Python with C, right? In this example, and we want to print the file content, right? So now if I just clear this, run, no. So you read the file content, read text. This probably won't do anything, but let me just. Why'd that just get louder? Okay, so actually, let me go. This is what I need to do, actually. There we go. Boom. So what I did there incorrectly was I, replaced here. I used this correctly. I replaced, right? I had the method correctly associated with the content of the file to replace Python with C, but I was actually just printing this right here, the file content line. There's nothing saving this. It's like, it's just doing it, and then when it gets to here, it's just like, okay, it just did that arbitrarily, and it's just pulling back from line 5. So we just had to re-save file content as this. I mean, I'm sure we could probably just put, dot replace right there, just the same, right? And even like just free up some lines of code here, and that would probably do the exact same thing. Yeah. But I'm gonna leave it as I had before, just because I think it's a little bit easier for a beginner to follow when I upload this to a repo. Cool. So that was okay. Cool. It says reading each line from the file you just created. So, I mean, this did the job. So, it's fine. Let's go ahead and we'll touch 10_3 simpler code.py. Let's go ahead and open this. The program file_reader.py in this section uses a temporary variable lines to show how split lines works. You can skip the temporary variable and loop directly over the list that split lines returns for line in contents.splitlines. Remove the temporary variable from each of the programs in this section to make them more concise. Bruh. For line in lines. For line. I'm not sure what this one's asking, so I'm just gonna go ahead and skip it. This question is kind of stupid. Wish I wouldn't do these ones where you have to like mess with the examples. Writing to a file. One of the simplest ways to save data is to write it to a file. When you write text to a file, the output will still be available after you close the terminal, containing your program's output. You can examine output after a program finishes running, and you can share the output files with others as well. You can also write programs that read the text back into memory and work with it again later. Writing a single line. Once you have a path defined, you can write to a file using the write text method. To see how this works, let's write a simple message and store it in a file instead of printing it to the screen. From pathlib, import path. Path equals path programming.txt, path.writeText. I love programming. The write text method takes a single argument, the string that you want to write to the file. This program has no terminal output, but if you open the file programming.txt, you'll see one line, I love programming. This file behaves like any other file on your computer. You can open it, write new text in it, copy from it, paste it, and so forth. Python can only write strings to a text file. If you want to store numerical data in text file, you'll have to convert that data to a string format. Can only write strings to a text file. If you want to store numerical data in a text file, you have to convert that data to string format first using the stir function. You'll have to convert the data to string format first using the stir function. Oh, you have to convert the numerical data to string format to save it. Okay, so you can only save strings. Writing multiple lines. The write text method does a few things behind the scenes. If the file has path points, if the file that path points to doesn't exist, it creates that file. Also, after writing the string to the file, it makes sure the file is closed properly. Files that aren't closed properly can lead to missing or corrupted data. To write more than one line to a file, you need to build a string containing the entire contents of the file and then call write text with the string. Let's write several lines in the programming.txt file. Contents, I love programming. Content plus equals I love creating new games. Contents plus I love working on data. Path equals path programming.txt. Path.write text context. Write contents. We define a variable called contents that will hold the entire contents of the file. On the next line, we use the plus equals operator to add to the string. You can use this as many times as you need to build strings of any length. In this case, we include new characters at the end of each line to make sure each statement appears on its own line. If you run this and then open programming.txt, you'll see each of these lines in the text file. I love programming. Okay, you can also use spaces, tab characters, and blank lines to format your output, just as you've been doing with terminal-based outputs. There's no limit to the length of your strings, and this is how many computer-generated documents are created. Be careful when calling write text on a path object. If the file already exists, write text will erase the current contents of the file and write new contents to the file. Later in this chapter, you'll learn to check whether a file contents exists using pathlib. Okay, 10.4 guests. This one we need to use a problem involves text. So we'll just touch 10 for guest up high. Let's open up this guy. Write a program that prompts the user for their name. when they were spawned, write their name to a file called guest.txt. So we just want to simply take in an input. So we want to create a name, and we want to take in an input from a user, and then we want to take what is your name, right? And then with that, we want to we need to actually import from path, import path. We need to take in this, we need to create a file called with a path. We need to take the path of let's path, what's it called? What do you want it to be called? Guess.txt, right? And then, so we take our input, and then we want to take file.write text, and we want to do this to we want to write the name input. So if we clear this terminal and run, we get what is your name. It's Michael. We get text.txt, Michael. So now if we run this again, let me go ahead and just format this a little bit. We run Michael Deming. This should override. Boom. Nice. Write a while loop that prompts users for their name. Collect all names that are entered, and then write these names into a file called guest_book.txt. Make sure each entry appears on a new line in the file. Write a while loop that prompts users for their name. Okay. So we first need to touch 10-5-guest_book.py. Let's open up this guy. We want to run a while loop. So while true, let's go ahead and do the following. Prompts users for their name. So we still want the name input, and we want to use the input function. We want to get what is your name. We'll format this accordingly, right? We will then continually ask or enter a guest, right? Right? So we need a way to get out. So continually ask name We want to continue after this, or let's just ask for a name. If name equals 0, name is equal to quote 0, right? For a stir, we want to break and print we want to from pathlib import path, right? We want to go ahead and open the file that we want to save. Click to guestbook.txt. File is path guestbook.txt, right? And then we want to file so we need a names, or we need guests. Let's do this. Let's do here. If guest for guest and guest if guest Let's make a list. We'll use that remove to remove the 0. Or I guess we don't need to do this actually if we just create an else statement that says guess dot append guess, right? We want to add that to the list. So then file dot write. We want to write text. We want to write the guest list. Right, so we just start out with an empty guest list, right? Think of it just as a list of guests on a sheet of paper. It's empty. So while true, we want to just go and queue people. We want to see where we want to invite Mike. We want to invite Anna. We want to invite John. We want to invite Gerald. We want to invite, keep going. And then, oh, I'm done. So I'm going to press 0. And I'm going to stop asking. I'm going to stop looping. And then I'm going to add all of those guests. And then I'm going to add the guest if it's not 0. And I'm going to continue. Okay, so repeat. I'm going to have an empty guest list. I'm going to go through. I'm going to add a guest. If that guest was not quote unquote 0, I'm going to add another guest. Repeat. Not 0, add another guest. Repeat, add another guest. Not 0, add another guest. Not 0, add another guest. Oh, that's 0. Break the loop. Open the file. Write the file of guests. Okay, and then let's try this. So if we clear our terminal and run this, enter a guest. We want to invite Michael. We want to invite Gina. We want to invite Sky. We want to invite Lady. We want to invite, that's it. So we got an error here actually. Data must be in type stir, not list. Interesting. So you can't write a list. So I will not make this a list. I will just make this an empty string, I guess. And I will just not append, add we want to add the guest. Right. Now this is only going to, I don't think this is going to work. Yeah, so I need sort of differentiating. Do that. Aha. But you get a line up top. So actually we'll just put the new line that happens to come at the end. So now if we run this, let me clear here. Let's do Michael, Gina, Sky, Lady, Derek, John, Phil. Now we hit 0. Boom. Let's go. Okay, so what we did here was we imported path from pathlib or lib, path library. We created a guest, which is an empty string. Now we can't save list using path. Path only saves strings, right? Not integers, not lists, strings. So I guess we could have kept the list and said for guests and guests, write guests, right? That probably could have worked. I kind of like that better. Let me try that. I get an empty list. Let's do guest dot append guests. Right? So this appends the guest. We import this and we say for guest in guests. So it's just gonna write each one. Right guest. So let me try that. Let me clear this. Let me actually wipe this. Run. So here we want to add Michael, Gina, Sky, Lady, 0. No, so it's overriding. If you do for guest and guest. How do I loop each one? I guess it doesn't. My other method was fine. I mean, it just used strings, which I guess you have to use in this context. Because if I run this, I enter guest, Michael, Gina, Sky, Lady, fart, 0. Right, I get it. So what I did here, just to explain, is I import the path, which is the object class, where I can actually get file paths as an object. I created a guest blank string, which when using path you can only save and write strings. So I created a string, not a list in this case. Now you probably can use a list and take elements from the list and write them, but I'm not gonna worry about that right now. So while true, so we're going to continually get guests from the user. We're going to prompt the user for a guest. Pardon me. If the guest, right off the jump, if they enter a 0 for the guest, we're going to break our loop. Else, we're going to add the guest to our guest string, right? We're gonna, whatever they put in, we're gonna add it to our guest string, and we're gonna create a new line and just keep adding in guests one after the other. Now, when the user finally enters 0, we will go ahead and open or create using the path object imported from pathlib. We save that file just as a variable called file. Then using that variable, we write using this method, write text. We write the actual guest string list in this case. And as you can see, we get this. Cool. Exceptions. Python uses special objects called exceptions to manage errors that arise during a program's execution. Whenever an error occurs that makes Python unsure of what to do next, it creates an exception object. If you write code to handle that exception, the program will continue running. If you don't handle the exception, the program will halt and show a traceback, which includes a report of the exception that was raised. Exceptions are handled with try except blocks. A try except block asks Python to do something, but also tells Python to do what to do if an exception is raised. When you try except blocks, your program will continue running even if things start to go wrong. Instead of tracebacks, which can be confusing for users to read, users will see friendly error messages that you've written. Handling the zero division error exception. Let's look at a simple error that causes Python to raise an exception. You probably know that it is impossible to divide a number by 0, but let's ask Python to do it anyways. Print 5 divided by 0. Python can't do this, so we get a traceback. Traceback most recent called last file division calculator.py. Line 1, division error. 0 division. The error reported in the traceback 0 division error is an exception object. Python creates this kind of object in response to a situation where it can't do what we asked it to. When this happens, Python stops the program and tells us the kind of exception that was raised. We can use this information to modify our program. We'll tell Python what to do when this kind of exception occurs. That way, if it happens again, we will be prepared. Using the try except block. When you think an error may occur, you can write a try except block to handle the exception that might be raised. You tell Python to try running some code, and you tell it what to do if the code results in a particular kind of exception. Here's what a try except block for handling the zero division exception looks like. Try Python 0 or 5 divided by 0, except zero division error, print you can't divide by 0. We put print 5 divided by 0, the line that causes the error, inside of a try block. If the code in a try block works, Python skips over the except block. If the code in the try block causes an error, Python looks for an exception block whose error matches the one that was raised and runs the code in that block. In this example, the code in the try block produces a zero division error. So Python looks for an exception block telling it how to respond. Python then runs the code in that block, and the user sees a friendly error message instead of a traceback. You can't divide by 0. If more code followed the try except block, the program would continue running because we told Python how to handle the error. Let's look at an example where catching an error can allow a program to continue running, using exceptions to prevent crashes. Handling errors correctly is especially important when the program has more work to do after the error occurs. This happens often in programs that prompt users for input. If the program responds to invalid input appropriately, it can prompt for more valid input instead of crashing. Let's create a simple calculator that does only division. Give me two numbers and I'll divide them. Print enter Q to quit. Let's see. Enter quote to quit. Alright. While true, first number equals input. What's the first number? If first number equals Q, break. Second number equals input. Second number. If second number is equal to Q, break. Answer equals int, first number divided by int, second number, print the answer. So basically just prompting for first and second number, dividing the first and second number, yada yada. This program prompts the user for input in the first number, and if the user does not enter a Q to quit, a second number. We then divide the two numbers and get an answer. The program does nothing to handle errors, so asking it to divide by 0 causes it to crash. It's bad that the program crashed, but it's also not a good idea to let users see tracebacks. Non-technical users will be confused by them in a malicious setting. Attackers will learn more than you want them to. For example, you'll know the name of your program file and they'll see a part of your code that isn't working properly. A skilled attacker can sometimes use this information to determine which kind of attacks to use against your code. The else block. We can make this program more error resistant by wrapping the line that might produce the errors in a try except block. The error occurs on the line that performs the division, so that's where we'll put the try except block. This example also uses an else block. Any code that depends on the try block executing successfully goes in the else block. Try answer first exit. Let's print answer. Yeah. We asked Python to try to complete the division operation in a try block, which includes only the code that might cause an error. Any code that depends on the try block succeeding is added to the else block. In this case, if the division operation is successful, we use the else block to print the result. The except block tells Python how to respond when a zero division error arises. If the try block doesn't succeed because of the division by 0 error, we print a friendly message telling the user how to avoid this kind of error. The program continues to run and the user never sees a traceback. Cool. The only code that should go in a try block is the code that might cause an exception to be raised. The only code that should go in a try block is the code that might cause an exception to be raised. Sometimes you'll have additional code that should run only if the try block was successful. This code goes in the else block. The except block tells Python what to do in case a certain exception arises when it tries to run the code in the try block. By anticipating likely sources of errors, you can write robust programs that continue to run even when they encounter invalid data and missing resources. Your code will be resistant to innocent users' mistakes and malicious attacks. Handling the file not found error exception. One common issue when working with files is handling missing files. The file you're looking for might be in the different location. The file name might be misspelled, or the file might not exist at all. You can handle all of these situations with a try except block. Let's try to read a file that doesn't exist. The following program tries to read in the contents of Alice in Wonderland, but I haven't saved the file alice.txt in the same directory as alice.py. So we import path from pathlib. Path equals path object with an input of alice.txt. Contents equals path.readText. And then we give it some sort of encoding. Note that we're using the read text in a slightly different way here than what you saw earlier. The encoding argument is needed when your system's default encoding doesn't match the encoding of the file that's being read. This is most likely to happen when reading from a file that wasn't created on your system. Python can't read from the missing file, so it raises an exception. And file not found. There. This is a longer traceback than the ones we've seen previously, so let's look at how you might make sense of the more complex tracebacks. It's often best to start at the very end of the traceback. On the last line, we can see that a file not found exception was raised. This is important because it tells us what kind of exception to use in the except block that we'll write. Looking back near the beginning of the traceback, we can see that the error occurred at line 4 in the alice.py. The next line shows the line of code that caused the error. The rest of the traceback shows some code of the libraries that are involved in opening and reading from files. You don't usually need to read through or understand all of these lines in a traceback. To handle the error that's being raised, the try block will begin with the line that was identified as problematic in the traceback. In our example, this is the line that contains read text. So try to read that, except file not found. In this example, the code in the try block produces a file not found error, so we write an exception alice.txt. Why would this is no 4. Alice.py line 4. In the file alice.py, the next line shows the line of code that the error caused. The rest of the traceback shows some code and the libraries are involved. And begin. So you can call the path alex.txt, save it as path, but try to read the contents of that path. Python runs the code in the block when the file can't be found, and the results are from the error message instead of traceback. The program has nothing more to do, so the file doesn't exist. Let's build on this example and see how exception handling can work more than one file. Analyzing text files containing entire books. You can analyze text files containing entire books. Many classic works of literature are available as simple text files because they are in public domain. The text used in this section come from the Project Gutenberg. Project Gutenberg maintains a collection of literary works that are available in the public domain. and it's a great resource if you're interested in working with a literary text in your programming projects. Let's pull in the text of Alice in Wonderland and try to count the number of words in the text. Let's do this, and we'll use the string method split, which by default splits a string wherever it finds any white space. Let's pull in. And try to count the number of words in the text. And to do this, we'll use the string method split, which by default splits a string wherever it finds any white space. So we import path alex.txt contents equals path.readText, except for file not found, else count the appropriate number of words in the file. Okay, so words equals content.split, so split all the contents. So split returns, let me just create a new file here. So I just do name equals name.split returns every word as a string in a list. Okay. So we call split length of words the file path that has number of words. I move the file as to the correct number directory. So the try block will work this time. We take the string contents, which now contain the entire text of Alice in Wonderland, as one long string, and use split to produce a list of all the words in the book. Using length on this list gives us a good approximation of the number of words in the original text. Lastly, we print a statement that reports how many words were found in the file. This code is placed in the else block because it only works if the code in the try block was executed successfully. The output tells us how many words are in Alice text. The file alice.txt has about 29,594 words. The count is a little high because extra information is provided by the publisher in the text file used here, but it's a good approximation of the length of Alice in Wonderland. Working with multiple files. Let's add more books to analyze, but before we do, let's move the bulk of this program to a function called count words. This will make it easier to run the analysis for multiple books. So yeah, it just moves it to a function. Most of this code is unchanged. It's only been indented and moved into the body of count words function. It's a good habit to keep comments up to date when you're modifying a program, so the comments have also been changed to a docstring and reworded slightly. Count the program to the file. Now we can write a short loop to count the words in a text we want to analyze. We do this by storing the names of the file we want to analyze in a list, and then we call count words for each file in the list. We'll try to count the words for Alice in Wonderland, Siddhartha, Moby Dick, and Little Women, which are all available in the public domain. I've intentionally left Siddhartha.txt out of the directory containing wordcount.py so we can see how well our program handles the missing file. So from pathlib, import path, def, count words, file name, takes in file name, counts the words of the file, returns the file count, okay. Returns that formatted string, right? File names equals alice.txt, Moby Dick, Little Women, so for file name and file names. Path equals path file name, path each file name, and then count words for each path, okay. The names of the files are stored as simple strings. Each string is then converted to a path object. Before the call to count words, the missing Siddhartha text file has no effect on the rest of the program's execution. The file Alice has about 29,000. Moby Dick, Little Women. Gotcha. Using the try-except block in this example provides two significant advantages. We prevent our users from seeing a traceback, and we let the program continue analyzing the text it's able to find. If we don't catch the file not found that Siddhartha raises, the user would see a full traceback, and the program would stop running after analyzing the Siddhartha. It would never analyze Moby Dick or Little Women, failing silently. In the previous example, we informed our users that one of the files was unavailable, but you don't need to report every exception you catch. Sometimes you'll want the program to fail silently when exception occurs, and to continue on if nothing happened. To make a program fail silently, you write a try block as usual. I was going to say pass, but you write a try block as usual, but you explicitly tell Python to do nothing if the except block. Python has a pass statement that tells it to do nothing in a block. Yep. The only difference between this listing and the previous one is the pass statement in the except block. Now, when a file not found error is raised, the code in the except block runs, but nothing happens. No traceback is produced, and there's no output in response to the error that was raised. Users see the word counts for each file that exists, but they don't see any indication that a file wasn't found. The pass statement also acts as a placeholder. It's a reminder that you're choosing to do nothing at a specific point in your program's execution, and that you might want to do something there later. For example, in this program, we might decide to write any missing file names to a file called missingfiles.txt. Our users wouldn't see this file, but we'd be able to read the file and deal with any missing texts. Deciding which errors to report. How do you know when to report an error to users and when to let your program fail silently? If users know which texts are supposed to be analyzed, they might appreciate a message informing them why some texts were not analyzed. If users expect to see some results but don't know which books are supposed to be analyzed, they might not need to know what's going on here. If users expect to see some results but don't know which books are supposed to be analyzed, they might not need to know that some texts were unavailable. Giving users information they aren't looking for can decrease the usability of your program. Python's error handling structure gives you fine-grained control over how much to share with your users when things go wrong. It's up to you to decide how much information to share. Well-written, properly tested code is not very prone to internal errors, such as syntax or logical errors. But every time your program depends on something external, such as user input, the existence of a file, or availability of a network connection, there's a possibility of an exception being raised. A little experience will help you know where to include exception handling blocks in your program and how much to report to users about errors that arise. All right, page 200. Try it yourself. 10.6 through 10.10. All right, I think I'm going to take a little break right there with Python Crash Course. Page 200 is a good place to stop. We're almost halfway, getting close. Really learned a lot so far, but still got a lot to go. Thanks so much for watching.